Good morning, everyone. Today we're going to talk about the evolution of the horse. We're going to start by looking at this drawing of a old-fashioned way of doing phylogenetic trees. You can see that we've got this idea that there are common ancestors, and then we've got branches with different species. So some are still here today. So Equus, which is the classic horse, still exists today, but other branches have disappeared, so these species are today extinct. Just a little point of awareness. In these more old-fashioned ways of representing evolution, there are two things which can be a little bit problematic. The first one is that species are placed where you would expect common ancestors to be, so that can be a little bit confusing. And the second one, you've got this idea that evolution tends to go to one type of species, which in this case would be the horse, which is not the case. It's just how things happen in a random way. So just be aware of that. However, it still gives you a nice picture of how horses have evolved. And we're going to focus on one main aspect. I'm going to change color. We are going to have a look at different body parts of these different horses, and what we're going to try and show is that most of the first group of species, so these ones, so we've got Mesophus, Orohippus, these ones were browsing horses, so they mainly fed on shrubs, fruits, leaves, etc. And we're going to try and show that because of different mutations, different characteristics have appeared, have been selected, and the more recent species in this big horse family, they are adapted to grassland areas. So we're going to try and show that these more modern species of horses, well, they are grazing horses. That is to say that they mainly eat grass. Well, just to stick with the booklet, the task that you have to do is explain how the change in structure in the evolution of the horse reflects adaptation to a changing environment. So we're going to have a look at different documents to establish this and show how characteristics were more adapted to different environments. At the end, we'll write some key points to answer this task. The first thing we're going to look at is just the global size of the different types of horses. So these are drawings which try to represent what these horses would have looked like. So we can see that when you go from left to right, towards the left are older species, and towards the right are more recent species. So we can see that in terms of size, throughout evolution, horses have become bigger. In terms of sizes, you can see that gradually mutations which provoked an increase in the growth of the species has been selected, and we end up with horses which are much bigger. The next thing we're going to look at is the size of the skull. So same thing, Eohippus had quite a small skull, and again, as you go throughout time evolution, again, it's an increase that's been selected, and you can see that the head of the modern horse is almost 3 to 4 times bigger. And you can also see that the teeth are bigger than those of Eohippus, and later on we'll look into more detail as to what are the specific characteristics of the teeth. So the two first things we can say is that in terms of global size, modern horses are bigger and their skulls are bigger. We've talked about the global size and the size of the skull. We are now going to have a look at the legs, and also we're going to have a look at the teeth. So the toe, foot, leg part. So what's striking, again, there's an increase in size. So a modern horse leg is almost 3 to 4 times bigger. Other interesting points are the following. You can see here that there are lots of little bones, whereas here we've only got 1, 2, and a hoof. So what's happened? The toes, the number of toes has been reduced from 4 to 1. So there's been a fusion throughout different mutations throughout time. These 4 toes have fused into 1, and the cushions, you would have had cushions here, have been replaced throughout the mutation again by a hoof. What about teeth? Well, teeth, they have become, so they were quite short, they were low-crowned teeth, and they became much longer. So the molars are bigger, they're longer, and also, so for the modern horse, you can see it here, they're much flatter, and you can see like little ridges on the teeth. So these ridges, they help to grind grass, just like a mortar and a pestle. It's going to help grind grass which contains silica. So you need more robust teeth to grind this grass and not be damaged by the silica which is found in grass. Silica is a mineral which will destroy, well, damage teeth. So if the teeth are more robust, flatter with ridges, that will help grind grass. Let's recap the 4 key points. First thing, modern horses are bigger. Second thing, they have bigger skulls. If we talk about the legs, they're longer, toes are fused, and there is the presence of hooves. And last thing, concerning the teeth, they're longer, they're bigger molars, which are more adapted for grinding grass. Along with these 4 recaps, you also need to know the difference between browsing and grazing. So browsing is when herbivores will mostly feed on leaves, soft shoots, fruits, etc. Whereas grazing is when herbivores feed mostly on grass. Now that we've done the recaps and the difference between browsing and grazing, we're going to try and put all these elements together and really understand why the family of horses evolved in such a way. Okay then, let's put all the pieces of the puzzle together to really understand why horses evolved in such a way. So the key thing is to understand that horses have evolved from being browsing species towards grazing species. Let's have a look into browsing first. So these are examples of other animals which are browsing different shrubs. The first thing which we can state is that you can see in the background there are small trees, shrubs. So that means that potentially these animals can camouflage or be less visible by predators. So if an animal is smaller, it will have more chances to avoid predators. Another thing, the fact that the toes are split, that can maybe help move sideways, turn around quite quickly. They're not going to be extremely fast animals, but they will be able to go sideways, turn, and go around bushes, try and flee from their predators. Obviously, we'll see that later, but in terms of natural selection, if an individual survives more, they are more likely to have offspring, and therefore the characteristics that that individual had will be transferred to the next generation. So the first types of horses, they were small, and being small is more adapted to shrublands. As for the teeth, we saw that there were smaller molars, so they're more adapted for eating fruit, leaves, which don't have so much silica, and that means that the teeth don't need to be as robust, don't have to be as solid to resist the damaging effect of silica. That was for the first types of horses, and throughout evolution, different mutations occurred, and we end up with the modern horse. Modern horses tend to live in grassland, in plains. And how can we link to what we've seen? We know that they're much bigger, so they're much more they're much stronger, so they can resist predators much easier. I think you've probably heard this, but you must never walk behind a horse, for example, because they've got tremendous power. If you're hit by a horse, that could almost knock you out. So they're very powerful, very muscular animals. So they would resist more easily. They could fight off predators more easily, and that is adapted to the environment because there are no trees, no shrubs to hide from. So horses which were more resistant, bigger, well, they survived more and they transferred their characteristics to their offspring. We also talked about the teeth. The teeth are more adapted for grinding grass, which is rich in silica and can damage the teeth potentially. So all this can explain why with the changing of the environment from shrublands to plains, this is how the horse family evolved. And last thing I've just realized I forgot, the fact that the toes have fused and you've got these long legs, these powerful legs that also can enable horses to run away if really gets too dangerous, and can run away in quite fast speed. That's all for this video. I'll see you next time. Bye.
Bye.